Hi all, this is going to be lecture 24. Now we're going to be graphing here, so I didn't type notes for you, but this is lecture 24. And this is from section 6.3, graphs of trig functions. Okay, so graphs of trig functions. So we want to know, what do these trig functions look like when we graph them? Okay, we know what they look like on a unit circle. We know how to find values, but what does this look like on a graph? So if we start with y equals sine of x. Well, in order to graph a function, we know we can start by using a table of values. So let's do that. So my x and my y's. And I'm going to go with 0, pi over 2, pi, 3 pi over 2, and 2 pi, right? So I'm going to go one time around the circle, okay? And we're going to get these values from our unit circle. So our unit circle looks like this, where this is 1, 0, negative 1, 0, 0, 1, and 0, negative 1. And we know that this first coordinate represents the cosine of the x, of the angle, and the second one is the sine. So as I go around my circle, I'm going to want the value in the second coordinate. So for angle 0, which is this one, I want 0. For pi over 2, I want 1. For 3 pi over 2, I want 0. And for 3 pi over 2, I want negative 1. And when I get back all the way to 2 pi, I also want 0. Okay, so if we jot those down up here, that was a 0, and then a 1, and then a 0, and a negative 1. And then all the way back to 0. Okay, so they coordinate. So we started green, blue, green, purple. Okay, so now we want to graph those. Okay, so 1, 2, 3, 4, 1, 2, 3, 4, but really this is going to be pi and 2 pi. And notice, if I look at my unit circle, that the highest number I get in this direction is 1, and the lowest is negative 1. The highest over here is 1, and the lowest is negative 1. So all of our values are going to stay between 1 and negative 1. So I'm going to have negative 1 and 1, and every given thing is going to stay within that. All right, so we have 0, 0. We have pi over 2 and 1, pi and 0, 3 pi over 2 and negative 1, and 2 pi and 0. And we get what we're going to call the sinusoidal wave that comes through here like this. And then we would just continue to extend it. So this one's actually going to go down first and then come back up like this. Okay. All right, now notice a couple of things here. So we get this kind of nice curve. It's continuous, so we don't have to pick up a pencil. When we draw it, it doesn't have any breaks in it. It stays between negative 1 and 1, and that's what we're going to call our amplitude. So the value of the number of units you go above and below 0 is your amplitude. So we go up above 1 and below 1. So our amplitude here is equal to 1. Okay. The period, we often talk about the period of a trig function. So you want to know how far does it go before it repeats itself. So essentially we get this section that we graphed and then it repeats. So that the period here is 2 pi. Okay, because it goes from 0 to 2 pi and then it starts to repeat and repeat and repeat. Okay. So one other thing that we want to notice is we want to take a look at what happens in the symmetry, right? Now, this is not symmetric at 0. If I folded this at the y-axis, it's not going to match up. But it is symmetric in exactly the opposite way, because if I go over here to pi over 2, the value up here is positive 1. But if I go to negative pi over 2, the value is negative 1. So they're the same but opposite signs. And so what we get is this ends up being what we call an odd function. So we make a note here that sine is an odd function. And in mathematics, odd just means that if you plug in the opposite sign, you get the opposite sign. So, for example, we had the sign of negative pi over 2, and that was -1, and that's negative the sign of pi over 2, which was +1. Okay, and that's true for all x's. So the definition to show that something's odd, we would say this. The sign of -x is equal to the opposite of the sign of x. It almost looks like you can kind of pull that sign out. The algebra doesn't work that way, but because it's an odd function, it does. Okay, and that's our sine function. So next, we want to go ahead and graph our cosine. So for the cosine of x, we want our table of values. 0, pi over 2, pi, 3 pi over 2, and 2 pi. So for cosine, we want the opposite. For sine, we wanted the second coordinate. Now I want the first coordinate. So I'm going to start at 0 degrees. So over here. And I want the first coordinate. So I'm going to start at 1 this time. Then for the blue angle at pi over 2, I'm at 0. And then for the green one, I'm at -1. And that's for pi. Let me move that up there. And then for 3 pi over 2, that's the purple one down here at the bottom, I'm at 0. And 2 pi is back to the beginning again, so that's going to be my 1. So if we graph that one in the same kind of way, this is pi and 2 pi, negative pi and negative 2 pi. And the same kind of thing is true for cosine, right? Those values don't go above or below 1 and -1. So that means this time I get 0, 1. So I'm starting up at the top. At pi over 2, I'm at 0. At pi, I'm at -1. 3 pi over 2 is 0, and 2 pi is back at 1. So I get this kind of repeating pattern. So the same kind of curve, only it's shifted a little bit. So if I do that over here, continue it, it's going to look like this. Okay, and so now you can see the same kinds of things. So first of all, the amplitude, again, is the same. So the amplitude here is equal to 1. And the period is also 2 pi, so that's the same. Because right here, I get everything I need to know in 2 pi, and then it starts to repeat. Right? I go start at 1, end at 1. Okay. Now, cosine, if we look at the odd, kind of the values, if I go to pi and go down, that gives me -1. And at negative pi, I actually get the same thing. It's symmetric left and right. If I were to fold it on the y-axis, I get the same exact thing. So what we say here is that cosine is, we're going to make a note, cosine is an even function, meaning it's symmetric along the y-axis. You can fold it at the y-axis and it will match up. So that tells you that the cosine of pi was equal to the cosine of negative pi. They had exactly the same values. And that's true for any x. So the cosine of x is equal to the cosine of negative x. They get the same exact value. Okay, now, you can adjust these functions to change the amplitude and the period. Okay, you can also shift them left and right a little bit. Now, we're not going to talk too specifics about a lot of that. The only thing I do want to mention here is how you change the amplitude, because changing the amplitude is pretty straightforward, because you can do that by changing the number that's in front. So if you take y equals 2 times the sine of x, then you're essentially taking all of your x values, so 0, pi over 2, same values, 0 pi over 2, pi, 3 pi over 2, and 2 pi. And you're just going to double whatever you got before. So we had 0 times 2 would be 0, 1 times 2 would be 2, 0 times 0, 2 is 0. Negative 1 times 2 is negative 2. And 0 times 2 would be 0. Okay, and then when we graph that, you can see that what it does, this is pi and 2 pi. Now, when I go, I still start at 0, 0, but now at pi over 2, I want to go up to 2. 0, and then negative 2 and 0. So you get the same exact curve, only instead of going up and down to 1, now you're going up and down to 2. So the amplitude here now is equal to 2. Okay, and again, that's how far above and below the axis it goes. And so what happens here is essentially we have y equals, I like to call it a times the sine of x. And the same thing is true for cosine. Then a is equal to your amplitude, right? So whatever number is sitting out front is the amplitude of your function, okay? Now, how do I change the period and the shifting? Well, that happens inside the sine function. So that we start changing the x that's inside there. Okay. We're not going to do too much about that, but just know that that does not affect your amplitude at all. Okay. So if I had y equals 4 cosine of 2x, this number right here tells me that this is the amplitude is equal to 4. And this number is going to tell you that the period changes. Okay. It actually changes your period by dividing it by 2, right? So you divide by whatever number's in front of the x, but we're really not going to worry too much about that for right now. Most things that we're concerned about is that the amplitude changes, and that's the number out front. Okay, so those are our sines and cosines. Those are the ones that I really want you to know really, really well. Okay, the other 4 we're going to run through so that you can see them, but I'm not super concerned about you knowing them for sure. Okay, so let's go to tangent. So table of values, same kind of thing. 0, pi over 2, pi, 3 pi over 2, 2 pi. And if we get our unit circle back here, this is 1, 0. Nope, it's not. It's 0, 1. This one is 1, 0. This one is 0, negative 1. And this one is negative 1, 0. Okay, so now tangent, remember that tangent is sine x over cosine x. We're using that basic identity here. And remember that the first coordinate is your cosine and the second is your sine. So I'm taking the second coordinate divided by the first coordinate. Okay, so at 0, so that's this angle, you're taking the second divided by the first. So this is going to be 0 divided by 1, and that's just 0. Next, at pi over 2, all the way up here, you're taking the second over the first. So that's going to be 1 divided by 0. And we can't divide by 0, so this is undefined. Okay, at pi, you're taking the second over the first. So that's 0 divided by negative 1. And that just is 0, right? Divided through on your calculator comes out to be 0. And then at the bottom, we've got our 3 pi over 2, and that's the negative 1 divided by 0. But you can't divide by 0, so this one's also undefined. And then when you get all the way around to the blue one again, that is your 0 divided by 1. So that's just 0. So what happens when a function is undefined? Well, typically when it's undefined, because it's a fraction, it ends up being an asymptote, and that's what happens with tangent. So that means tangent is going to have an asymptote at pi over 2 and 3 pi over 2. So 1, 2, 3, 4. This is pi. This is 2 pi, which means at pi over 2 is this one. And I'm going to draw a dotted line because it's undefined here. And the same thing at 3 pi over 2. Okay. And then at 0, and also, by the way, if we do the same thing this way, then we're going to get at negative 3 pi over 2 and negative pi over 2, we're going to get them there as well. So that when we go to graph this, we have 0, 0 as a point, and pi 0 as a point, and 2 pi 0 as a point. And what happens is you've got to ride along this axis, and it ends up looking like this. Okay, all the way across. So you get some asymptotes, and then it's going to rise from left to right. Notice, is tangent odd or even? Well, it's not symmetric. If I folded it along the y-axis, it's not. But if I folded it down and then over, then it is, right? So opposite here. So if I went here, I go up. If I go the same place across here, then I go down. So they're opposite values. So we would say that the note tangent is an odd function. Okay. Now we don't talk about amplitude with tangent because it's going to go up and down forever, right? Because along that asymptote, it's going to go to positive and negative infinity. It's just going to kind of ride as close as it can and go all the way up. So let's take a look at cotangent next. So y equals cotangent x. And we know that cotangent x is the reciprocal, right? So this is 1 over the tangent of x. So we're just going to take the reciprocal of the values here. So if we had x and y, and before, up top, we had 0 over 1, flip it over. So 0, pi over 2, pi, 3 pi over 2, 2 pi. Now we had 0 over 1, so now we're doing 1 over 0, and that's going to be undefined. Right? What's going to happen is our asymptotes are going to switch. Pi over 2, we had 1 over 0, so now it's going to be 0 over 1, and that's just 0. Pi over, for pi, we had negative 1 over 0, or now you get negative 1 over 0, and that's going to be undefined. This one will become a 0 over negative 1, and that's 0. And if you take the reciprocal of 0 over 1, we get 1 over 0, and that is undefined. So now instead of having asymptotes at pi over 2 and 3 pi over 2, our asymptotes are going to shift. So now our asymptotes are going to be at 0, pi, and 2 pi. So same thing over here, negative pi and negative 2 pi. And we're taking reciprocals. So that means you're going to get a very similar thing here. So here we go. Here's what this one looks like when we go to graph it. So we've got up here when we were to the right, right? So you're flipping these values upside down. You're taking positive values from 0 to pi over 2, and you're flipping them upside down. They're going to stay positive values. So from 0 to pi over 2, it's going to be positive. So that means here, it's going to be positive, and then it's going to become negative, and positive, negative. So it kind of flips things a little bit. Okay. But again, you can talk about this, again, doesn't have an amplitude because it goes up and down forever. But you can see that the period here is just this one because we repeat the same thing here. So the period is really just pi because between 0 and pi, we get everything we need. The same thing is true up here for tangent. The period is equal to pi because I can get everything I want between negative pi over 2 and positive pi over 2. And if you take those two distances and add them together, pi over 2 and pi over 2 is positive pi. Okay. And a quick note here that cosine is is not symmetric, right? If we folded it, it would not match. So this one is also an odd function. So cotangent is an odd function. Okay, and then again, that's because when you go here and up and here and down, you get the same value, but they're now opposite signs. And let's go to our last two. For y equals secant x. Get our 5 values. Okay, now these are the secant is the reciprocal to cosine. So we're flipping cosine values over here. So this is 1 over cosine x. So we're going to essentially go up to our cosine, which are these, and we're going to flip them over. So when you flip over 1, you're going to get 1. When you flip over 0, you get undefined. So we're going to get 1, undefined, -1, undefined, 1. So we're going to get 1, undefined, -1, undefined, and 1. Okay, and what that's going to look like is slightly different than secant and tangent. Same kind of ideas, but a little bit different. So pi and 2 pi. And our asymptotes this time are going to happen at pi over 2 and 3 pi over 2. But instead of going through 0, now at 0 we get 1. So we get this point, and we get, at pi, we get this point. So what happens is we end up with this. They're kind of little U shapes. Okay. Here, we can note that this is symmetric. So let's see, secant is an even function. And its amplitude, we don't talk about amplitude because the arrows go up to infinity. But you can talk about the period. We've got to go from 0. We need this piece, these pieces, and this piece. So the period here is 2 pi as well. Okay. And then the last function we want is cosecant, which is going to be very similar. That's 1 over the sine. So we're going to flip over the sine values. And this is essentially going to just switch. So 0, pi over 2, pi, 3 pi over 2, and 2 pi. So instead of having our undefineds at pi over 2, our undefineds are going to be at 0, pi, and 2 pi, just like they were for cotangent. So undefined, undefined, and undefined. And the others are going to be 1 and -1. Okay, so when we graph it, we're going to get the same kind of graph. Only now our asymptotes are going to be at 0, pi, 2 pi. And our values are going to be at 1 and -1. -1, 1. And we get the same kind of shapes. Okay, so again, we're not going to talk about the amplitude. This one, if you fold it at the y-axis, it's not symmetric, but it is odd. So we're going to make a note. Cosecant is an odd function. Okay, and the period here is also 2 pi because we need this piece and we've got to go all the way out to 2 pi to get it. Okay. And those are our 6 trig function graphs.